The first problem is the pressure problem. It's asking you to find the pressure exerted by a 2.2 kilogram ball on the tip of your finger, and the area is 1.1 centimeters squared. The area of the finger is 1.1 centimeters squared. So what's the pressure exerted by the ball on the tip of your finger? So the formula for pressure, if you remember, is pressure is pressure is force over area. That's force over area. Okay, so this is number 1, and force exerted by any object is the weight. Okay, so when you put the ball on the tip of your finger, the weight of the ball will exert the force. That means the force comes from the weight of the ball. And then that's over area. So weight is given by this formula. If you guys remember, we talked about the weight. Weight is mass times acceleration due to gravity. Okay, that's the formula for work, and that's area. So now we have pressure is given by mass times acceleration due to gravity over area. Mass is given 2.2 kilogram. G is, we already know the value of G. We have used that in several contexts. So that's 10 meters per second squared is the value of G, and the area is given 1.1 centimeters squared. Now we have meter on the top here and centimeter on the bottom here. So we need to make the units uniform. Whenever we do any kind of problem, the units need to be same. Okay, so that means we need to convert this centimeter squared into meter squared. So the conversion is 1 centimeter is 1/10 of a 1/100th of a meter. So that's 0.01 meter. Okay, 1/100th of a meter is 1 centimeter, and centimeter squared means we have centimeters times centimeter. So 1 centimeter times 1 centimeter is centimeter squared. So that means we need to convert twice, okay, for each centimeter. So for this centimeter, it is 0.01 meter, and for this centimeter also it's 0.01 centimeter or 0.01 meter. So we need to convert both the centimeters. That means we have 2.2 kilogram on the top, 10 meter per second on the second squared on the on the same side, and on the bottom we have 1.1. Okay, and centimeter squared, that's the conversion for centimeter squared. That times 0.1 times 0.01. Okay, this is just the conversion, and meter is meter squared. Okay, so we need to do the calculation. So let's see what you get. Anyone has calculator? So can you do the math and see what you get? So let's do the math. Come on, let's go down. Let's see, I want to make it smaller. So we have 2.2 times 10 okay, and that divided by 1.1, that divided by 0.01, and that divided by 0.01. So that gives us 200,000. Okay, so this is 200,000, and the unit of pressure is Pascal. So Pascal. Okay. So basically, again, you need to find the force over area. In this case, the force is the weight of the ball, and weight is given by mass times acceleration due to gravity. Okay, that's what you have. And then the other thing you need to keep in mind is when you have area in centimeters squared, you need to convert this 1.1 centimeters squared into meters squared. So 1.1 centimeters squared is 1 times 0.1 meters squared. Okay, so that's the conversion, and that gives you the meters squared. Okay, so let's look at number 2. A 12 kilogram piece of metal displaces 2 liter of water when submerged. What is the density of the metal? So this is number 2. So we have some water. You put 12 kilogram piece of metal in the water, and as a result, let's say there is a hole here. Okay, it displaces water, and how much water it displaces? It displaces 2 liter of water. Okay, so we want to find the density of the metal. The formula for density is, what do you guys know about the formula? Do you guys know the density? How do you find density? What is? Huh? Yeah, exactly. So mass divided by volume is the density, mass over volume. So we need mass. Mass is given 12 kilogram, and we need volume, but the volume is not given. How do we find volume? We know that when you place an object in water, if the object is fully submerged, then this object will displace the volume of water equal to its own volume. Okay, same volume of water as its own volume. That's the displacement principle. That means if it displaces 2 liter of water, so the equivalent of 2 liter in cubic meter is 2 liter is or we can write in centimeters also. So 1 liter is, let's see the conversion. Okay, so liter into, we want to express this into a meter cubed. Okay, that's the standard unit. So we want to see the conversion factor. I just want to make sure if that's right. So 1 liter to 1 meter cubed or cubic meter. So 1 cubic meter is 1000 liter. So the conversion is, let's see, 1000 liter is 1 cubic meter, but we have only 2 liters. So, 1 liter would be 1 over 1000 cubic meter. Okay, that is the conversion. If 1000 liter has 1 cubic meter, then 1 liter will have 1 over 1000 meter cubed, and then 2 liter will have 2 over 1000 meter cubed. Okay, so that is the volume of the metal, because the metal displaces the same volume of liquid as its own volume. So, we have mass given 12 kilogram, and we just found the volume. Volume is 2 over 1000 meter cubed. So, the density would be 12 kilogram is the mass, volume is 2 over 2000 would be 0.002 meter cubed. Okay. And then you do the calculation. So, 12 over 0.002, that gives us 6000 kilogram on the top and meters cubed on the bottom. So, 6000 kilogram meter cubed is the density of the metal. Okay. So, that answers number 2. Okay, let us look at number 3. So, please read the question and see what it is asking. On a perfect fall day, you are hovering at rest at low altitude in a hot air balloon. The total weight of the balloon, including its weight and the hot air in it, is 22,000 Newton. How much volume does the hot air balloon displace in order to keep it floating in air? Okay. So, we know the principle of flotation. So, this is from chapter 5 again. So, principle of flotation. We just saw the sinking object displaces the same volume as its own volume, but now let us talk about flotation. So, when an object is placed on water, the object will float on water, it will float, it will not sink. If the object displaces, if it displaces the weight of the liquid equal to its own weight. Okay. So, this is the principle of flotation. If you want to float on water, then you need to displace the weight of water equal to your body weight. If you can do that, then you will float. If you cannot displace the weight of water equal to your own weight, then you will sink. Okay. So, that means to float the balloon, so the balloon has the weight, okay, so including all the load and everything, it has the weight of 22,000 Newton. So, that means it needs to displace. This principle is applicable not only to water or liquid, it is also applicable to air. Okay. So, applicable to both air and liquid. So, that means the balloon has to displace that much air in order for it to float. Okay. So, air needed to be displaced. Is equal to 22,000. Okay. So, that much air would be displaced, but it is asking for the density of air, not sorry, it is asking for the volume of the air, not the weight. Okay, we want to find volume. So, this is the weight. With weight you can also find the mass, because we know weight is mass times g. So, mass of the air would be, doing a little bit of rearranging here, that would be weight over g. Okay, so, if I want to know the weight of this air, I need to divide this by g, okay, 22,000 Newton over g. So, what is the value of g? It is 10 meters per second squared. That means it would be 2200 kilogram. Okay. Mass is the total matter which is measured in kilogram. Weight is the force, okay, force of the earth on the object, and weight is always 10 times more than the mass, because it is m times g. So, we got mass, we want to find volume. So, what is the relationship between mass and volume? I think we talked about that in the previous problem. So, what is the relationship between mass and volume? Why don't you guys look at the previous problem? Mass and volume are related by density, right? Density is mass over volume. That means mass would be density times volume, right? That is how mass and volume are related. Mass is equal to density times volume. So, or you can also write this as volume is equal to mass over density. Okay. So, different ways to write the same thing. So, this is the definition of density. If I rearrange this, I can get this, and if I rearrange that, I can get this one also. Okay. Just doing the cross multiplication, I can get that. So, volume is equal to mass over density. So, in order to find the volume, I need mass and density. We know the mass, this is the mass, but we do not know the density. So, what is the density of air? It is not given here. When you do not have that, usually it is given in the question, but if it is not given, you can Google that. So, density of air. If it is exam question, you would be provided the value, but sometimes when you are doing homework, you may need to find that from the Google. Density of air. Let us say at sea level. It is about 1.1, 1.2. So, here it says 1.2. So, we will consider it 1 to 1.2 kilogram per meter cubed. So, we want to find volume. Volume is mass 2200 kilogram. Density is 1.2 kilogram per meter cubed. So, do the math. If we do the math, let us see what you get. 2200 over 1.2, that gives us 1833.33. 33.3. So the unit of volume is, this will cancel kilogram and kilogram, so this will result meter cube. So in order to float, the balloon needs to displace 1833 cubic meter of air. If it displaces less than that, it will sink. If it displaces more than that, it will rise up. Okay. If it displaces exactly same amount, it will just stay in air without moving up or down. So let's look at number 4. Any question on this one? Any question? No? Okay, so let's look at next question then, if you don't have any question on this one. A 0.20 meter times 0.40 meter times 0.60 meter block is suspended from a wire and is completely under water. What is the weight of the water displaced by the block? What is the volume of the water displaced by the block? What buoyant force acts on the block? Okay. So usually when we do this kind of numerical questions, it's always good idea to draw a picture or figure that will help us to visualize the scenario. So we have a block that is suspended from a wire and is completely underwater. Okay, so that's a block suspended with some wire and it's under the water. And the volume is given. Okay, so volume of the block we know the formula for volume. Volume is length times width times height, which is what this thing is. So 0.2 meter times 0.4 meter times 0.6 meter. That's the volume, length, width and height. If I do the calculation, I get, so come on, clear that out, 0.2 times 0.4 times 0.6, that gives me 0.048. 0.048, that's the volume, and it's meter times meter times meter. So volume is meter cubed or cubic meter. So that's the volume. So let's first answer B, because B is pretty straightforward. We already know from the previous problems. If the block is completely submerged in water, it will displace the same volume of water as its own volume. Okay, so answer B is volume of liquid displaced, volume of water displaced, because it's completely submerged, so it will displace same volume of water as its own volume. That is the volume of the block. So volume of block we just found 0.048 cubic meter. Now let's go to part A. What is the weight of the water displaced by the block? We want to find the weight. So weight, what is the formula for weight? We just use that. You guys remember formula for weight? What's the formula for weight? Huh? Yes, so it's m times g, mass times g. So we want to find weight. To find weight, we need mass and we need g. G is known, okay, it's always 10 meters per second squared, that's the constant. But mass, we want to first find the mass, okay, to find the weight. So in order to find the weight, we first need to find the mass. We don't know the mass of the water, but what we know is we know the volume. And what is the relationship between mass and volume again? I just mentioned that couple of moments ago. Yeah, so mass is equal to volume times density, or density times volume, because the definition of density is mass over volume. If I rearrange this, I can take this to the other side, so it will become mass is equal to density times volume. Okay, so that means I need to find mass, and to find the mass, multiply density and volume. And the density of water, again you can Google that. If it is test, it will be provided in the test, but if you are doing homework or something, so you can just Google that. I know the density is 1000 kilogram per meter cubed, but just to show you how you find that. So density of water, so 1000 kilogram per meter cubed. So it's actually 997, but usually just for simplification we just use 1000. Okay, but you can use this exact number if you want, 997 kilogram meter cube, but here I'm going to use 1000 kilogram per meter cubed. That's the density. So mass is density times the volume we have is that 0.048 cubic meter. So we need to multiply these two numbers. If we do that, what we get? So that times 1000, that gives me 48, and the unit of mass is kilogram. Okay, so now I got the mass. With that I can find the volume, or sorry, with that I can find the weight. Okay, so weight is mass times g, which is 10 meters per second squared. I'm using this formula here. So 48 times 10 is 480. Okay, weight is force, so it's Newton. Weight is measured in the unit of Newton. So that answers number 4A. Now we have to answer number C also, 4C. So let's look at C, part C. What is the buoyant force on the block? Buoyant force. So there are two ways to find the buoyant force. Okay, the definition of buoyant force is how much, when you place an object in liquid, how much force the liquid exerts on the object. Okay, the upward force. And the way you can find the buoyant force is measure the weight in air, measure the weight of the object in air, and measure the weight of the object in liquid or water, and subtract the weight in water from weight in air. That gives you the buoyant force. Okay, buoyant force is that. And from Archimedes' principle, we have Archimedes' principle. A couple of weeks ago we talked about this Archimedes' principle. What it says is, when you submerge an object either partially or fully in liquid, okay, when you submerge this object in the liquid, this liquid will displace, this object will displace some liquid, and the weight of this liquid, okay, Archimedes principle, I am talking about Archimedes principle, the weight of the liquid displaced, the weight of this liquid, that is equal to the buoyant force on that object, B U O Y A N T, buoyant force. So more the liquid displaced by the object, more the buoyant force this object will feel. Okay, that's the Archimedes principle. So we can use this principle to answer this. So our buoyant force from Archimedes principle, buoyant force is weight of the liquid displaced, which is what? We already found that. What is the weight of the liquid displaced? Yes, 480 Newton. Okay, that's the answer for part C. So that answers number 4. So these are all from chapter 5. Okay, we talked about all the concepts. Now we are looking at some of the numerical questions. Okay, let's look at number 5. And 5 is also from chapter 5. So the volume of air in marshmallow blaster is 434 milliliter. So you have air in some cylinder. Okay, so that one has V1. V1 is the initial volume before you squeeze it, 434 milliliter. Okay, so you have a piston here, and when the volume is that, the pressure of the gas or the pressure inside this cylinder is 110000 Pascal. Okay, that's the pressure. That's the pressure and volume. Now you squeeze it, squeeze the air, and reduce the volume to 100 mil, okay, 100 milliliter. And when you do that, the pressure will be increased. Now we need to find what's that pressure. Okay, so when you compress the air, that increases the pressure. So what would that pressure be? Any idea how you find that? And this is done at a constant temperature. Okay, so we are not changing the temperature. So this is all at constant temperature. Any idea? Yeah. So we use excuse me, Boyle's law. That's called Boyle's law. Which gives us this formula: P1 times V1 is equal to P2 times V2. Okay. So we want to find V2 P1 is 110000 Pascal. V1 is 434 milliliter. P2 is unknown. V2 is 100 mil. Okay. So in order to get P1 on this right side, divide both sides by 100 mil. So you cancel that 100 and 100, and P2, and you do the math. Okay, so it's 20 and 20 I can cancel, so that will give me 434. Now let's just do the calculator. Let's use the calculator. We have 1100 times 434. So that gives me 477400. 477400. 477,400 Pascal. Yes. So in order to get rid of this, I divided both sides by 100. I divided that by 100 and 100.
Okay. I was right whenever you did that. I
Yeah.
didn't see that.
And then I can cancel the 2 zeros on the numerator here, 2 zeros on the denominator.
Right.
Yeah. Okay. So that's the Pascal's principle. Now let's look at number 6. Sorry, that's the Boyle's law. Now number 6 is Pascal's principle. So let's look at that. We have this hydraulic system. So you lift a car on this side by applying some force on this side. So you apply the force. So here on this side we have 1200 kilogram car. So the piston here has the radius. So the piston is a circular piston like this. Okay. Although it seems flat here, but it's a circular piston. So that piston has the radius of 0.150 meter, and the piston on this input side has the radius. Let's call this R2. This is R1. That one has 0.012 meter. Okay. Again, it's the cylindrical piston. This is also cylindrical piston, and this is filled with some kind of liquid. It could be oil or some other liquid. So the question is, in order to lift this car, how much force you need to exert on this side? Okay. So we want to find the force. Now this is based on Pascal's principle. Pascal's principle tells us when we apply some pressure on one side, the pressure would be transmitted to all the parts of the liquid undiminished. Okay, it will appear same amount of pressure on each and every part of the liquid. That means if I exert pressure P1 on this side, I get the same pressure on this side. Okay, let's call this pressure on the left and pressure on the right. Whatever pressure I apply on this side will appear on this side without without diminishing, without any decrease in the value. So that means PL would be equal to PR. Pressure on right is equal to pressure on left. We know the formula for pressure. Pressure is force over area. So this pressure is force over area. That pressure is also force over area. That's the formula for pressure. So we cannot write F and A here because they are not same. Okay, so I need to write, because area is different, force is different. So I need to write here L to denote that it's on the left side, and I need to write here R to denote it's on the right side. So this is what I want to find. So that means I want to write this in terms of that quantity. So to do that, I can multiply both sides by this AL and AL. Okay. Just to get rid of that, I want to multiply both sides by AL. So cancel AL and AL. That means I will have FL left on the left side. So then FR over AR times AR AL. Okay, so that formula gives me the force on the left. So FR is the force on the right. How much force you are exerting on the right? So on the right, we want to lift the car. That means in order to lift the car, we want to apply the force equal to the weight of the car. Okay. So the weight of the car is mass times g, and in order to lift that, we want to apply the same amount of force. So force will be equal to the weight of the car. So this would be equal to mass of the car times g, okay, because that's the weight, over area of the right side piston. What is the area of this circular piston? We are given the radius. You have a circle. What is the area of this circle? You might have done this in some math. Do you remember area of a circle? It's pi r squared. That's the area. And so we are talking about the area on the right side. So pi, radius of the piston on the right side, squared. Area on the left side is pi, radius of the piston on the left side, squared. Okay. So pi and pi are common, so you can cancel them. Now mass of the car is 1200. G, we already know what G is. It's 10 meters per second squared. Radius of the piston on the right side is 0.150 meter, and we also have square here, so don't forget square, otherwise you will get wrong answer, times radius of the piston on the left side is 0.012 meter, that's squared. Okay. So let's do the math. So I can use calculator to do that. So I have 1200 1200 times 10 times 0.012 squared, that divided by 0.15 squared Something is wrong. Okay, clear that. Memory clear. Okay, so let's do that again. So 12. Uh-huh. Okay, so let's look at that again. Okay, because the ordinary calculator sometimes it's when you do that square, it doesn't do it in correct order. So that's why you need to use a scientific calculator. So that times, so square means it's multiplying the quantity 2 times. So I can just do that. Okay, so 1200 times 0.012 times 0.012, that's square. Okay, and divided by 0.15, again divide by same thing, divide by, because we have square, so I need to divide it twice. 0.15, so that's 76.8. That gives me 76.8 Newton. .8 Newton, which is in kilogram. This would be 10 times less. So if you, this is the force, but if you want to put some mass here, how much mass you will need? You will need only about 7 kilogram. So by putting about 7 kilogram of mass, you can lift 1200 kilogram car. Okay, that's the magic of physics. Just by applying this small amount of force, you can lift so much force, I mean so much like weight. Okay, so let's look at number 7. This is 7 is from chapter 6. Any question before I erase this? No? Okay. Let's look at number 7. Number 7 is not that difficult conceptually, but math could be a little bit tricky, because if you haven't seen the kind of math, I mean you might have done this in some algebra, but yeah, you might not have seen this kind of math in this kind of physics context. We did the lab similar to this question. If you were in the lab, you might have seen this, but if you are not in the lab, it may be a new thing for you. So basically it says that you have 500 gram of water at room temperature. So again, make a picture. So you have mass of water is 500 gram, so that much mass of water, and this water is at room temperature, means the temperature of water is 21 degrees Celsius. Okay, that's the room temperature. You have a piece of copper. The mass of the copper is 200 gram, and the copper is initially at 100 degrees Celsius. So the temperature of copper is 100 degrees Celsius. So when you put this copper in water, okay, and then you stir that mixture, you cover that with some styrofoam or something, so that the heat doesn't skip to the environment. So now the temperature of this mixture, okay, temperature of this mixture, final temperature, let's call that final temperature, that is what we need to find. What would be the temperature of the mixture? So what would be the final temperature after mixing that copper and water? The principle here is pretty straightforward, basic principle. When you mix the copper and water, the copper will lose the heat, and that lost heat would be gained by water. That means heat gained by water comes from heat lost by the copper. And when you talk about loss, we need to put minus sign. Like if you have $1,000 to begin with, if you lose $500, so your final amount is 500, initial amount is $1,000, so change is minus 500. So this minus means you lost something. Okay, so whenever you say loss, you need to put minus sign. So that means heat gained by water is equal to negative of heat lost by copper. That's the basic principle. And heat gained or heat loss is given by this formula. Okay, so heat is mass of the object losing or gaining the object, losing or gaining the heat, specific heat capacity of the object times change in temperature, final temperature minus initial temperature. Okay, so this is the formula to find the heat. So for water, let's talk about the heat gained by water. Heat gained by water is mass of water. Okay, that's mass of water. C is specific heat capacity of water, and change in temperature of water. Change in temperature is final minus initial for water. Okay. Likewise, heat lost by copper. Heat lost or heat gain is given by this formula. So mass of copper, specific heat capacity of copper, and change in temperature of copper, T final minus T initial of copper. So now everything is plugging in the numbers and doing the math. So let's plug the numbers in. Mass of water 500 gram. Specific heat capacity of water is given. It is 4200 joules per kilogram per degree Celsius. That's the specific heat capacity. Final temperature is what we need to find. Okay, that's the final temperature. Final temperature of water. That's the water after mixing the copper. So we want to find that. Initial temperature of water. What's the initial temperature of water? What's the initial temperature of water? 21 degrees Celsius. Minus mass of copper is 200 gram. Specific heat of copper is given 386 joule per kilogram per degree Celsius. Final temperature of copper, need to find that. Initial temperature of copper is 100 degrees Celsius. Okay. So we can cancel this gram and gram unit, same unit. 2 zeros on this side and 2 zeros on this side. You can cancel that. So now we need to do the math. This is the hardest part. Okay, so 5 times 4200. Let's do the math. Clear. How do I clear that? clear. So 5 times 4200, that gives me 21,000 TF minus 21. Okay. On this side we have 2 times 386, that's 772 TF minus 100. Okay. So I can get rid of this 772 by dividing both sides by that. 772, okay, get rid of that. Now 2100 over 772, clear. 2100 divided by 772 gives me 27.20. So on this side we have 27.2 TF minus 21 minus TF minus 100. So now let's do the math. So 20, you need to multiply each of the terms in the parentheses. So 27.2 TF minus 27.2 times 21. Let's clear that. 27.2 times 21, that gives me 571.2. This minus, we need to multiply this minus to the both terms. So minus TF, this minus times minus gives us plus 100. Okay. Now we want to write this in terms of TF. So add TF on both sides because we want to get rid of TF on the right side. Okay, so I am adding TF and TF on both sides because they will cancel. That would give us 0. So I can add without any consequence. So when I do that, I will cancel this one and this one because we have minus TF and plus TF, so they cancel. So now these two add up. TF plus 27.2 TF is 28.2 TF. Okay, they add up to that. Now I want to write the left side in terms of TF, so I want to get rid of this on left side. That means let's add that quantity on both sides. So 571.2 and 571.2 on both sides. So when I do that, I cancel this one and this one. Now I only have TF on the left side. On the right side I have 571.2 plus 100 is 671.2. Okay. So I want to get TF, so divide both sides by 28.2 because I want to get rid of that. That means TF